Hello everyone, this is Dr. P. Srilatha, Associate Professor, Department of Mathematics, Institute of Aeronautical Engineering, Hyderabad. In this session, we are going to discuss about chi-square distribution. So before that, what is small sample and what are the methods are there in small samples, we will discuss. Okay, so test of hypothesis for small samples. So small sample means if n is less than 30. If the sample size is less than 30, then we can say that is small sample. So actually, there are three types are there in test of hypothesis for small samples. So first one is T distribution, second one is F distribution, and third one is chi-square distribution. But in T distribution, we have two methods. Two more methods are there. First one is T distribution for single mean, and second one is T distribution for difference of means. So now we will discuss about the chi-square distribution. So what is a chi-square distribution? Chi-square distribution. So to test whether there is any significance difference between observed and expected frequencies, we use chi-square test. To test whether there is any significance difference between the frequencies or between the observed and expected frequencies, we use this chi-square test or chi-square distribution. So the formula is, the test statistic is chi-square. This is not x square, this is chi-square. So chi-square equal to summation y minus ei whole square by ei, where y is the observed frequency and ei is the expected frequency. Okay, so before that, observed frequency is nothing but our given frequency. Given frequency. So what about expected frequency? So for expected frequency is nothing but we need to calculate this expected frequency from the observed frequency. So for this expected frequency, to find the expected frequency, we have three methods. So method 1, in method 1, we have to take the expected frequency by using average of all observed frequencies. Average of all observed frequencies. In method 2, we have to find the expected frequencies by using binomial distribution or by using Poisson distribution. And the third method is, so this is totally based on row and columns. That means here we need to find the expected frequencies by using row total into column total divided by grand total. So by using this formula, we can find the expected frequencies. Okay, so in chi-square distribution, we have three methods to find the expected frequencies. So based on the expected frequencies, we have three methods. So first one, second one, third one. So that first one is average of. We need to find the expected frequencies by using average of all observed frequencies. Okay, so average of all observed frequencies. In first method and second method, so in first method and second method, the chi-square value we have to choose in from the table, that is nu equal to n minus 1 degrees of freedom. So that means chi-square alpha. So here we need to take chi-square alpha value at nu equal to n minus 1 degrees of freedom. So in first method and in second method, we have to take chi-square alpha equal to chi-square alpha value at nu equal to n minus 1 degrees of freedom. So like that in third method, okay, chi-square alpha value at nu equal to row minus 1 into column minus 1 degrees of freedom. Okay, so but here now we are going to discuss about method 1. So method 1 is nothing but here we need to find the expected frequencies, ei values, that are nothing but expected frequencies. So we need to find the expected frequencies by using average of all observed frequencies. Okay, so average of all observed frequencies is nothing but here in method 1, that is expected frequency. Problems. So now coming to the first problem, the number of automobile accidents per week in a certain area as follows: 12, 8, 20, 2, 14, 10, 15, 6, 9, 4. Are these frequencies in agreement with the belief that accidents were same in the during last 10 years? So how many values are there here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So total 10 values are there. So that means n equal to 10. So but here we need to find the observed frequencies. So what are the observed frequencies? I think we have discussed about observed frequencies. The given frequencies are observed frequencies. That means these are all OI values. OIs, observed frequencies. These are all 12, 18, 20, 22, 14, 10, 15, 6, 9, 4. So these are all observed frequencies. That means OI values. Okay. So next we need to find the expected frequencies. So what is the expected frequency in method 1? So in this problem. So that is average of all observed frequencies is our expected frequency. So what is the average of this one? So 12 plus 8 plus 20 plus 2 plus 14 plus 10 plus 15 plus 6 plus 9 plus 4 divided by total number of values are 10. Okay, so 10. So average of this one is 10. So that means here the expected frequency is 10. So observed frequency is these values. These frequencies are observed frequencies. In every observed frequency, in place of every observed frequency, we need to write the expected frequency. So that as 10. Okay. So now coming to the table. So here OI values are these are OI values and these are EI values. So 12, 8, 20, 2, 14, 10, 15, 6, 9, 4. So these are our expected frequencies. At the expected frequency, we need to write all 10s. Okay. So next we need to find OI minus EI whole square. So that means 12 minus 10, that is 4 whole square. Sorry, 12 minus 10, that is 2 whole square, that is 4. 8 minus 10, minus 2 whole square, that is 4. So 20 minus 10, that is 10. 10 whole square is 100. So like that 2 minus 10, 8 whole square is 64. So like that the last value is 4 minus 10, that is minus 6 whole square, that is 36. So like that we can calculate y minus EI whole square values. So next coming to y minus EI whole square by EI. So that means this square divided by, so this one divided by EI. So y minus EI whole square by EI. So that means 4 divided by 10, that is 0.4. So 4 divided by 10, that is 0.4. 100 divided by 10, that is 10. 64 divided by 10, that is 6.4. 16 divided by 10, 1.6. 0 divided by 10, that is 0. 25 divided by 10, 2.5. 16 divided by 10, that is 1.6. 1 divided by 10, that is 0.1. So next 36 divided by 10, that is 3.6. So sum all these values. 0.4 plus 0.4 plus 10 plus 6.4 plus 1.6 plus 0 plus 2.5 plus 1.6 plus 0.1 plus 3.6. So sum of all these values, that is nothing but chi-square equal to summation of y minus EI whole square by EI. So that is equal to 26.6. So this is our answer. So chi-square equal to summation y minus EI whole square by EI. So that is equal to 26.6. So next we need to follow our procedure. So what is our procedure? So first we need to write the null hypothesis, then alternative hypothesis, then level of significance, then test statistics. Here we need to write the formula and the conclusion. So what is the conclusion here? So the conclusion is, if chi-square alpha, modulus of chi-square less than chi-square alpha, we accept null hypothesis. If chi-square is greater than chi-square alpha, we reject null hypothesis. Okay, so this is our conclusion. Actually, conclusion. Okay, so now coming to our first step. What is our first step? Null hypothesis, that is denoted with H naught. So that is equal to Y equal to EI. Here I am taking Y equal to EI. That means observed frequency equal to expected frequency. So what is the meaning of Y equal to EI? So there is no significance difference between observed frequencies and expected frequencies. Okay, so the meaning of Y equal to EI is there is no significance difference between observed frequencies and expected frequencies. So next one is null hypothesis, that is denoted with H1. So this is nothing but Y not equal to EI. So that means there is a significance difference between observed frequencies and expected frequencies. So what is the meaning of alternative hypothesis? This is quietly opposite to the null hypothesis. That's why here I am taking Y equal to EI, nothing but Y not equal to EI. That means there is a difference between observed frequencies and expected frequencies. Next, coming to third step, level of significance. So that is alpha equal to 0.05. So here we need to calculate chi-square alpha at nu equal to n-1 degrees of freedom. Okay, so what is the chi-square alpha? What is the alpha value here? So they have not mentioned alpha value. So that's why here I am assuming that alpha equal to 0.05. So chi-square 0.05 at nu equal to n-1. So what is the value of n? That is 10. That is 10-1 degrees of freedom. So chi-square 0.05 at nu equal to 9 degrees of freedom. So we have to calculate this value from the chi-square distribution table. So we'll see. So we have to take chi-square alpha from this chi-square distribution table. So this is our chi-square distribution table. Okay, so chi-square critical values of the chi-square distribution. Okay, so chi-square distribution is this one. In this we have alpha values. So these are all alpha values. But here we need alpha value is 0.05. This is our 0.05. This column we need to choose. Okay, so next coming to nu value. So nu equal to n-1 degrees of freedom. So nu equal to n-1. 10-1 degrees of freedom means that is 9. So at 9 degrees of freedom. So at 9 degrees of freedom, alpha value is 16. So alpha value is 0.05. At 9 degrees of freedom is 16.919. So chi-square alpha value is 16.919. Here chi-square 0.05 at 9 degrees of freedom is 16.919. Okay, so we have taken chi-square alpha value from the table. So that value is 16.919. Next, to test statistics. So coming to the test statistics, here we have to use the formula. So what is the formula? Chi-square equal to summation Y minus EI whole square by EI. So already we have calculated this value from the table. Okay, so that value is 26.6. The value is 26.6. So, but we need mod chi-square. So if we have a chi-square value is minus 26.6, then we need to take chi-square. Mod chi-square is 26.6. We have to take every value as positive value. Okay, so that's why. Okay, but here chi-square equal to 26.6 only. So then mod chi-square value is 26.6. So coming to the conclusion, so chi-square, mod chi-square is 26.6 and chi-square alpha is 16.919. So 16.919. So 26.6 is greater than 16.919. So that means the calculated value. So mod chi-square we have taken from the we have calculated this value, and chi-square alpha value we have taken from the table. Okay, so that's why, so mod chi-square is greater than chi-square alpha. That means the calculated value is greater than tabulated value. So that's why we reject the null hypothesis. So here, see here, observe. So mod chi-square is greater than chi-square alpha. That means we reject the null hypothesis. So that means we reject our statement. So what is our statement? So here already we have written in the null hypothesis, that is, there is no significance difference between observed frequencies and the expected frequencies. So that is, our statement is wrong. So that means there is a significance. What is the answer here? There is a significance difference between the observed frequencies and the expected frequencies. So coming to the next problem, the following figure shows that the distribution of digits in numbers chosen at random from a telephone directory test whether the digits may be taken to occur equally frequently in directory. So here we have digits. Those are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So these are the digits in telephone directory, and the frequencies are here 1026, 1107, 997, 966, 1075, 973, 1107, 972, 964, 853. Okay, so these are all observed frequencies, OI values. Okay, so these are all observed frequencies. That means those are all OI values. So how many values are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So n equal to 10. Okay, so now coming to EI, expected frequencies. So what is the formula for expected frequencies? Okay, so average of expected frequency formula is here, average of all observed frequencies. Average of all observed frequencies. That means that is 1026 plus 1107 plus 997 plus 966 plus 1075 plus 973 plus 1107 plus 972 plus 964 plus 8053 divided by n value. N value is 10. So that is 1004. So we have to take expected frequency value in all the places, that is 1004. So these are all OI values, and EI. EI everywhere we need to write 1004 only. Okay, so these are all observed frequencies. Observed frequencies means the given frequencies. The given frequencies. So that means here next value is here we need to find OI minus EI whole square. That means 1026 minus 1004 whole square, that is 484. Like that 1107 minus 1004 whole square is 1069. So like that we need to find all the values. So after that we have table, that is OI minus EI whole square by EI. So this one divided by this one. So y minus EI whole square divided by EI. So 484 divided by 1004. We will get 48.4 approximately. So these are, here I am taking approximate values. So 1069, 1069 divided by 1004. So like that we will get 1060.9. So 1060.9. So this is also approximate. Here I am taking approximate values. You can take exact values also. So next, if you add all these values, we will get summation OI minus EI whole square by EI. So that is chi-square equal to. So chi-square equal to summation OI minus EI whole square by EI. That value is 5462.2. So next we need to set up the null hypothesis. The null hypothesis is denoted with H naught, that is equal to OI equal to EI. That means there is, the meaning of this value is OI minus EI equal to there is no significance difference between observed frequencies and expected frequencies. Okay. Next, coming to alternative hypothesis. Alternative hypothesis is nothing but opposite to the null hypothesis, that is denoted with H1. Okay, so opposite to the null hypothesis means here I am taking in the null hypothesis y equal to a I have taken. So, but in the alternative hypothesis that will be y not equal to ei. So that means there is a difference, there is a significance difference between observed frequencies and expected frequencies. Okay, so next, coming to the level of significance. Here in the question they have not mentioned alpha value, so that's why I am assuming alpha equal to 0.05. At 5% level of significance I am taking, so here that one we are assuming. Okay, assume alpha equal to 0.05. So now we need to calculate chi-square alpha in level of significance. In the third step we need to calculate chi-square alpha. That chi-square alpha value is at nu equal to n minus 1 degrees of freedom. Okay, so nu equal to, chi-square alpha 0.05 at nu equal to n value 10 minus 1 degrees of freedom. So that means that is chi-square 0.05 at nu equal to 9 degrees of freedom. So that value is also already we have chosen from the table, that is 16.919. Okay, so here the chi-square value is 16.919 we have taken from the table. Next, coming to the test statistic. Here we have to use the formula, so that is chi-square equal to summation y minus ei whole square by ei. So already we have solved in the table, that value is 5462.2. Okay, but we need to take modulus value. So modulus of chi-square equal to 5462.2. So that is 5462.2. And what about chi-square alpha? So the chi-square alpha value is 16.919. So this is 16.919. So is 5462.2 is greater than 16.919? Yes, that is. So that's why mod chi-square is greater than chi-square alpha. So if the calculated value is greater than tabulated value, then we reject the null hypothesis. That meaning is mod chi-square is greater than chi-square alpha, then we reject, according to our condition, we reject the null hypothesis. So that means we reject our statement. What is our statement? We have taken in the null hypothesis, that is there is no significance difference between the observed frequency and expected frequency is a wrong statement. So what is the correct statement here? There is a difference between, there is a significance difference between observed frequency and expected frequency. So that is the answer. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.